I'm going to show you something. This lesson comes from section 11.2 combined with a little from 11.7. The topic is centers of triangles. The objective. I can solve in student-friendly language problems involving this word, centroids. So copy that down. Thank you. Okay. So, first of all, what word in this objective makes you feel like, what the heck? What are we learning about? Centroids. And I think that it's really important to kind of know what a centroid is if we're going to solve problems involving centroids. So the first question I have for you is, what do you think the first logical question would be? How about, what is a centroid in the first place? Y'all see that? Okay, and I'm going to answer that, but the answer itself is going to require another question to be answered. So, first of all, a centroid is the point where the three medians intersect each other. Now that may or may not make sense, so what I'll do is I'll give it more meaning. How many of you know what a median of a triangle is? Because, listen, if you don't understand what a median of a triangle is, then this answer doesn't make much sense to you. The question was, what is a centroid? And a centroid is the point of intersection where the three medians of the three medians. So then the question becomes, what do you think the next question is going to be? What do you think the next question should be? I think so. Thank you. What is a median of a triangle? That's the question. Here's the answer. I'm doing this in fast motion. What is the median of a triangle? It is a line segment that connects the vertex to its to the midpoint of the opposite side. It connects a vertex to the midpoint of the opposite side. So it's a line segment that connects a vertex to the opposite side at the midpoint. Oh, I left the word side. Sorry about that. It's a line segment that connects the vertex to its opposite side at the midpoint, or you could say to the midpoint of the opposite side. I think a really good idea would be to give you a picture at this point. I'm just going to give you a picture. You know what they say, a picture says 1,000 words, so let's just show a picture. What I'm going to do is I'm going to draw a triangle. I'll use a straight edge. What the heck? Y'all see that line? I'll make another side. And then the third side. Okay, so there's a triangle. So draw a triangle, any old triangle you want. Doesn't have to be perfect, like me, because we all know I'm perfect. Not. Now, I'm going to ask you a question. In this particular triangle, you see this left side right there? I want to ask you to tell me to stop when you think I'm at the midpoint of this line segment. So if I'm going along this side here, tell me when to stop when I hit the midpoint. Anytime now. You think that's the midpoint? Yeah, what? Okay, try it again. Tell me when to stop when you think I'm at the midpoint. Okay, you said stop right there? Is that the midpoint? Okay, now, maybe you don't understand the assignment. Tell me when to stop when you think my pen hits the midpoint of this side right here. The middle. The dead center of this line segment. On your mark, get set, tell me when. Thank you. Dang, I like pulling teeth. Okay, so now if this truly is the midpoint, then by the definition of a midpoint, that means that this part of the side has to be congruent to this part of the side. Definition of midpoint. So I put one tick mark and one tick mark. But if I were to connect that midpoint to its opposite vertex, or this vertex to the midpoint of the opposite side, please help me. Amen. See how I just connected the vertex to the midpoint of the opposite side? That's called a median. I just connected the vertex to the midpoint of the opposite side. That's a median. Now do me a favor over here. Tell me, as far as this side's concerned, tell me when to stop when you think I'm at the midpoint again. Okay, I agree. Like about right there. And if that's the midpoint, then this segment's got to be congruent to this segment. Definition of midpoint. But if you were to connect that midpoint to its opposite vertex, or this vertex to the midpoint of its opposite side, like this, kind of, sort of, help me. That's also a median. Now we're getting a picture of where they intersect. The third median would be connecting this vertex to the midpoint of its opposite side, which would be somewhere, of course I'm not wearing my glasses, like around right there. And if that truly is the midpoint, then this segment is congruent to this segment. Definition of midpoint. Do you realize that I just drew in the three medians of the triangle? The line segment that connects the vertex to the midpoint of the opposite side. Y'all see that? Now, I want you to label this. We'll call this point A. Let's call this point B. Let's call that point C. Let's call that point D. And then we'll call this point what? E. Let's call that point F. And what do you want to call this point? Well, thanks. Point G. So copy that down. Because now I'm going to give you the concept. Shall I copy that? Like I said, it doesn't have to be perfect. But here is the concept. This is what the problems are based upon. Okay, kids, it goes like this. Pay close attention. Do you notice that point G is where all three medians intersect? That's called the centroid. And I'll explain to you in real life what a centroid actually is, or one of the aspects of a centroid. It's the balancing point. It means if you have any kind of triangle, I don't care what the triangle looks like, and if you find the centroid, that means if you put your finger at that point, you could balance the triangle on your finger and it won't fall. It'll just balance. As long as the triangle is made out of a solid piece of metal or wood, and the weight is consistent through and through. It's a balancing point. But here's what all your problems are going to be based on. Do you notice, like, for example, C median CF? That median, that centroid, that point right there, G, that chops up median CF into two segments. One segment is the short side, and the other is the long side. And you could see that GF is the short side, and the distance from G to the vertex is the long side. Can you all see that? But not only is it long and short side, but let's see if you have the idea. Look at median AD. Which one do you think is the short segment, from A to G or G to D? Which one is the short segment? G to D or G to A? G to what? D is correct. That's the short side. Here's the key. I'm going to give you concrete information. This is a concrete concept. The short segment is always half the distance as the long segment. For example, if I told you that this short segment right here was 12, then its longest side right here is going to be 24, because the short side is half the long side, and the long side is twice the short side. That's the relationship. What if I told you that from G to D was 8 units? From G to D was 8 units. What can you tell me about the distance from G to A? It is 16. Okay, Richard, you 2 for 2. Because the long side is definitely twice the short side. The short side is half the long side. Last question. What if I told you that this was, let's say 36? From G to E is 36. What can you tell me about the short side? $36, the short side has to be? Somebody? Got a calculator? Got a pencil? Paper? Do you think that's the short side or the long side? Okay, so what is the short side? It's half of 36, which is 18. That's the concept. So I'm gonna put that in words. When you find this centroid, it chops each median into a short segment and a long segment. So I'm going to put this in student-friendly languages, and you're not going to necessarily see this in a math book somewhere, but it's plain English to me. the long side equals 2 times the what? The long side is twice the short side. What do we know about the short side? Well, if the long side is twice the short side, then the short side must be what? Thank you again, Richard. Half the what? That's how we found this. Like if that was 24, half of 24 is 12. If that was 8, 2 times 8 was 16, that's 16. Now there's one more thing that I really want you to know. Two things I want you to know. One thing for sure is I want you to know that the short side equals the entire median divided by 3. The short side is 1/3 the entire median. The short side and the last one. If you know this, you're ready for anything that comes your way. The median, that means the length of the entire median, is nothing more than 3 times the length of the short side. So copy that, and we'll be on our way. And I'm going to show you how to use that information so you could be highly successful. Okay. So here we go. Copy. Huh? Let me finish this. We're recording right now, and I have a goal. Okay, kids, here we go. Check this out. Take your paper. We're going to fill this out together. And the first thing is, we're talking about medians and centroids. The median, this kind of defines it. Here it is in a picture. You connect the vertex to this midpoint of the opposite side. How do you know that's the midpoint? Because they're showing you that that's 1 tick mark, that's 1 tick mark. By definition, that's the midpoint. The median is nothing more than a segment. A segment joining a blank to the blank of the opposite side. What do you think you fill that in with? Look at the definition I gave you. A what? Yeah, a vertex. You're connecting a vertex to the blank of the opposite side. Here's the vertex. There's the midpoint. Thank you. So you're connecting the vertex to the midpoint of the opposite side. That's exactly what a median is. Now they're talking about the centroid. Okay? The centroid is the 3 blank of a triangle intersect at a point called the centroid. The 3 blank of a triangle. The 3 what? Somebody said it. The medians. Thank you. When you draw on those 3 medians, they intersect at a point called the centroid. So then we come over here and they show you a picture just like what I showed you. And it says, use the diagram to the left to answer the following questions. It says, list the medians. Well, the medians are just the line segments that connect the vertex to the midpoint of the opposite side. So the first one here is just line segment AE. It's right there. What's the next one? Can somebody give me another median besides AE? I'm sorry, what? DC. Very good. But you have to say line segment CD or DC. And what's the third one? Line segment BF is a good response. Yep, BF. Those are the three. Now let's continue. It says, name the centroid. It is point P. Perfect. Now it says, what special properties exist for each median? Well, let me tell you something. We went through those. These are the special properties. Sorry. These are the special properties. So I'm going to put it in kind of like student-friendly language, but I'm going to use symbols. Let's take a look at this first median, AE. All it's saying is that the long side, which is AP, and when you don't see anything above AP, it means the distance from A to P, that equals 2 times the distance from P to E. Remember, the long side is twice the short side. You could also say, look at this one. For BF, the distance from B to P, that's since B to P is the long side, that equals twice the distance from what? P to F, because PF is the short side. Remember, the long side equals twice the short side. Look at the third one. From C to D. We could say the distance from C to P, which is the long side, equals twice the short side. What's the name of the short side? P to what? D. Thank you. And now, the next thing that I think is really important to know is this. Remember I said right here, the short side equals the median, the whole entire median divided by 3. It's 1/3 of the median. So having said that, look at the first median, AE. So that just means that median AE, the distance from A to E, well, let's say the short side. Look at the short side PE. The distance from P to E, that's the short side. It equals the entire median. What's the length of the entire median? Well, that's going to be from A to E divided by 3. So that's the way of saying symbolically this short side is 1/3 of the entire distance. How about for BP? Sorry, how about for median BF? The short side, which is what? That equals the entire median BF divided by what? 3. And then let's look at CD. What's the short side of CD? Okay, so that means that the distance from P to D equals the entire median CD divided by what? 3. And now we're going to put those concepts to use so you could actually function independently. You might have enough time to finish this before you even leave, or most of it. But having said that, I'm going to do 3 problems for you. And once you see these 3 problems, there won't be anything else left new that you'll face. Look at number 1. When you do these problems, I want you to do them in 2 steps. Step 1, I want you to label the diagram. After you label, I want you to do this. My favorite word, generate. New information. Generate means to produce or to make or create. So in other words, this is what I mean. You're going to label and then generate. Label, then generate. So I'm going to zoom in on number 1. I know this is really small, but work along with me. Just work with me. And it goes like this. You see how it says that's the centroid? So you know each one of these are medians, which you know that this side is congruent to this side, This side's congruent to this side. You know that that's congruent to this. I'm just saying. But the point is, look at what they give you. The first information they give you is the distance from J to K is 22. So I label it. That means the distance from J, which is right here, all the way to K is how much? So I just labeled that. It's 22. But since this is a median, when I say generate information, before you go to the next piece of information, you could tell that because this is the midpoint, due to the fact that LM is a median, then that means the midpoint means, by definition, this side from K to M has to be, well, what's 22 divided by 2? 11. And by definition, midpoint from M to J is also what? 11. Let's go to the next given information. The distance from K to N is 13. Well, find K to N. Well, to me, K to N is right there. That's what? 13. Well, that's 13. What else is 13? Okay, so label it. That's generating. Now, because definition of midpoint. Now, the question is, if this segment is 13, that segment is 13, there's another piece of information you could generate. By segment addition postulate, what's the whole length of KL? Thank you for that. It's 26. That's called generating information. Because 2 times 13 is 26. Next, it tells you that OL is 18. Well, find OL. OL is 18. That's right here. What else can you figure out if that's a 18? Yeah, the other side. OJ or JO. 18. Not only that, but if this is 18 and that's 18, what do you think this whole thing is? And now you have enough information to fill these in. What's KM? All you got to do is look. Thank you. And what is NL? 13. Beautiful. And then what is KL? I'm sorry, KL is what? Gorgeous. Just like me. And what is JO? Perfect. And then J, and then LJ? 36. Done. Now I want to do 2 more with you. Any questions with that? Raise your hand if that's not that bad. Okay, look at this right here. We're going to label and we're going to generate. Look, it says TZ is 60. Well, first of all, find TZ. And right there, what is that going to be? Label it. I know it's puny, but... Now, do you think that's the long side or the short side of TY? So what's the short side? Beautiful. It's half. Excellent. That's called generating information. If XZ is 28, label it. Well, first of all, find XZ. It's right here. That's 28. Now, if that's 28, if that's the short side or the long side? Definitely the short side. The side that goes from the centroid to the midpoint, that's the short side. The side that goes from the centroid to the vertex, that's the long side. So that's 28. What's 2 times 28? You guys are awesome. Okay, and then finally it says WZ is 25. Well, first of all, WZ is right there. That's 25. Can you find ZU? Okay, 50. Now we can answer questions. What's ZV?
Huh?
56, thank you, because it's going from Z to V. What's ZY? 30. ZU? TY? T to Y? Well, think about it. T to Z is 60. Z to Y is 30. What's 60 plus 30?
90.
Excellent. Segment addition postulate. Good job. And then finally, XV. X to V. How'd you get that?
28 plus 56.
28 plus 56, which is what?
It went off.
So what is that going to be? 84. Perfect. And now the last one I want to do with you, so I can give you a chance to work independently, which is coming up in 2 seconds, is this one, number 4. It's important that I do number 4 with you. In number 4, they are going to give you the entire median length. The entire median length. They're going to give you the entire median length. So, like for example, from T to U is 27. From T to U is 27. If they give you the entire median length, remember what I told you. The short side is the median. Wait, where is? Sorry. The short side is the median length divided by 3. If you could take the median length and divide it by 3, that's the short side. Divide the median length by 3. In other words, what's the median length in this case?
27.
Right, it's 27. So if you take 27 and divide it by 3, what does that give you?
9.
So that means for TU, the short side is 9. Right there. That's generating information. Not only that, but since that's the short side, what is the long side going to be? It's always twice the short side. So if the short side is 9, then the long side is 18. Let's take a look at SW right there. This whole entire length SW is 18. So if we take 18, divide by 3, but where do you apply the 6? Do you apply it to the short side? So that's 6. Now, we're still trying to generate information. Is there any way to find that side? It's going to give you 12. And now they give you RV is 21. So since RV is the entire length, we could take 21 divided by 3. So what does that mean as far as the problem is concerned? Which side is 7, the left or the right? Yeah, that's 7. And if that's 7 right there, guess what? Guess what else you found? 14. Now you can answer this question. What's TX?
18.
Oh yeah, 18. Hello. What's XU?
9.
X. Oh yeah, it's 9. Hello. And then what's SX?
12.
Is 12. And XW?
6.
XW is 6. And then RX? RX is 14. Done. That's everything. I mean, that's like the whole... What I need from you is to do number 3. And then you flip it over, and good news is they're regular huge size, so you won't be all crowded. Finish all those. All this is adding or subtracting. Maybe a dividing. Maybe a multiplication, but there's nothing harder than that. So finish that, show me, and you get full credit. If you don't finish it today, you have to show me by tomorrow. Remember, put your name, the date, and then this is period 7. And start with this one. Remember, label it. 8. And get started. So if that's 8, you could find that. What is that piece? Okay. I'm not going to help you anymore. But if you have a question, you could walk over here. Get started right away. Get started right away. Okay. So please get started right away. If you're sleeping, I can't give you a grade. But good luck. You kids are awesome. I think you're going to do great. And that is the lesson.